Okay, let's look ahead. You sent us all the raw materials industry reports, developer surveys, market projections. And our mission today is to build your definitive strategy, really, for the programming technologies that are going to define 2026.
Exactly. And we're going beyond just, a simple list of what's popular.
Right. This is more of a technical roadmap you need to thrive. This whole deep dive is about strategic investment in your skills because the pace of change, it just demands you make informed choices, like right now.
And that strategic approach is so key. I mean, when you look at the sheer scale of the field, you realize how critical those decisions are.
The numbers are pretty staggering.
They are. Our sources confirm the tech sector is growing at, 15% annually, with projections for well over 1 million programming jobs in the U.S. alone by 2026. It's a massive landscape.
So it's easy to get lost.
Very easy. So we've drilled down into the high-impact areas, all backed by real data. Gartner reports, Stack Overflow surveys, even academic evidence on efficiency and cybersecurity. We want to see what skills offer the biggest return on your time.
Let's unpack that. Our goal for you listening is pretty simple. We want to identify the most in-demand technologies, explain why they matter, and, this is the crucial part, give you some actionable starting points.
Things you can actually do.
Exactly. We want you to feel the excitement of applying this, maybe with a fun little project you can tackle this weekend.
And the gains from this are tangible. We aren't just guessing here. Knowledge of these specific technologies, it directly multiplies your job opportunities.
You mentioned Python earlier.
Right, take Python. Studies show languages that are central to AI appear in, 47 to 58% of all AI-related job posts?
Wow.
So we're focusing on knowledge that is both applicable and aligns with, hard evidence and performance and security.
Okay, let's jump in. The first big theme has to be the core technologies, the foundation of modern software, AI and web dominance.
And you have to start with Python.
You have to. It really is the versatile king. Now, Python is famous for its low barrier to entry. And if you look at something like the TIOBE index, which tracks language popularity, Python's share is massive. But that popularity is only half the story.
It is. What's fascinating is that its power isn't just about popularity. It's rooted in its efficiency for AI, machine learning, and data science.
It's the ecosystem.
It's the whole ecosystem. We were looking at studies in IE, and they confirmed that Python's efficiency in rapid prototyping can reduce development time by something like 30% compared to compiled languages.
30%? That's huge.
It's a game changer. That speed of iteration is vital when you're building complex models.
Yeah.
And that's coupled with massive libraries like PyTorch, which is just foundational for deep learning. Python gives you the speed to move quickly and the tools to build, anything.
So how do you get your hands dirty with this without drowning in theory?
Right.
Forget the textbook. Here's a quick idea. Use the Python ecosystem. Maybe dip into Hugging Face, which is that huge hub for pre-trained AI models. And just create a simple chatbot that tells truly terrible jokes. It's fun, but you're learning how to load, customize, and apply AI models directly.
I love that. Practical and fun.
Okay, so moving from that back-end intelligence to the front end, the user interface, we hit web mastery.
And you can't talk about the web without JavaScript.
It's essential. It runs, 98% of all websites?
Yeah.
But the future of big, scalable web development isn't just JS. It's TypeScript.
TypeScript is basically JavaScript with guardrails. It adds this thing called types, which, it lets you define the kind of data a variable should hold.
Why does that matter so much?
Because for large, complex apps, especially those built on frameworks like React or Node.js, these types let you scale securely. They catch errors before your code ever goes into production.
So it's a safety net.
A huge one. And if we connect this to the bigger picture, Gartner's highlighting the growing role of AI in front-end development. And that's exactly where TypeScript's reliability and structure just shine.
And developers seem to love it.
They do. It's no surprise it's been ranked #1 in developer satisfaction in GitHub surveys as recently as 2025. It brings much-needed structure to the chaos of the internet.
Right. Another project idea for this stack, build a simple AI-generated meme app. Use the web layer, JS or TS, to pull images, and then maybe use a Python backend API to generate a caption. Instant, relevant, and you've just connected two essential parts of the 2026 stack.
That's a great project.
Okay, now let's change focus completely. We've talked about the surface layer, but what if you need to build the fundamental systems, where performance and security aren't just luxuries?
Where they're non-negotiable requirements.
Exactly. That transition takes us to the performance powerhouses.
And that brings us directly to Rust. Rust is so critical right now because it solves one of the biggest historical headaches in systems programming, memory management.
And the stats on this are pretty wild.
They really are. We saw that research from Microsoft confirming Rust can prevent a stunning 70% of memory vulnerabilities.
70%. That is a massive number.
Yeah.
For listeners who might not be systems programmers, can you break that down? What is a memory vulnerability, and why is preventing 70% of them such a big deal?
Yeah, that's a crucial question. A memory vulnerability is essentially a class of bug where a program mismanages or accesses memory it shouldn't.
Right, it goes somewhere it's not supposed to.
Exactly. And this is a common cause of serious system crashes, weird behavior, and, most critically, major security holes that hackers can exploit.
And Rust prevents this. How?
It achieves this safety without using a garbage collector like Java or Python do, which means you get the raw speed of a language like C++R, but with security features built in by default. It's security without sacrificing speed.
That sounds like an advantage that's too big to ignore. The only catch, as our source had pointed out, is the learning curve.
Oh, it's steep.
Developers joke that learning Rust is like scaling a mountain with code.
It is challenging, but it's also incredibly rewarding. For an actionable project, I'd challenge you to try this. Take a Python script you already wrote, something that does some heavy lifting, maybe processing a big data set, and just rewrite the core computational part of it in Rust. You compile it, call it from Python, and you will feel that performance difference instantly. That aha moment makes the climb worth it.
Okay, so sticking with performance, we have to talk about the cloud architect. Go, or Golang.
Right. While Rust is all about that memory safety for systems, Go is about scale and speed in the cloud.
And it was designed by Google, which I think tells you everything you need to know about its purpose.
Exactly. It was built from the ground up for concurrency, which just means handling many operations at the same time very efficiently. This makes it a perfect fit for microservices and cloud-native development, the back-end infrastructure that runs massive platforms like Kubernetes.
And the academic sources back this up.
Yeah, papers in the ACM consistently emphasize its efficiency in managing these concurrent operations under heavy load. Its demand is seeing this steady increase, about 2% a year. It's a required skill if you're building scalable network services.
And for a project idea.
For Go, try developing a simple API that can handle thousands of requests at once. And don't just build it, push it to its limit. See what it feels like to build something that just doesn't buckle under pressure.
All right, now we move to the big established players. These aren't necessarily the new trendy languages, but they are the foundational three that anchor every major part of the industry. The anchors. You ignore these at your peril.
Absolutely. While we talk about the newcomers, these established players still, run the world, especially in enterprise data and physical systems.
So with all this focus on new agile languages, why hasn't a stalwart like Java been completely displaced?
Because stability, predictability, and just massive existing infrastructure matter. Java is still a top 5 language on Stack Overflow because it runs critical enterprise systems and, of course, most of Android development.
And it's not standing still.
Not at all. It's not stagnant. Recent updates like virtual threads are boosting its efficiency for modern applications, keeping it competitive.
Okay, anchor number 2, SQL.
Structured query language. This is just indispensable for data management. It doesn't matter what your specialty is. Our sources show SQL is used by nearly half of all developers, and it is the essential skill for managing the massive data warehouses that feed all that hungry AI we talked about earlier. If you touch data, and everyone touches data now, you have to know SQL.
And the final foundational language.
Yes.
C++ where? This takes us all the way back to pure hardware performance.
It does. C++ is still the king of performance-critical systems and robotics. It aligns perfectly with what Gartner calls physical AI, the systems that actually interact with the real world.
So autonomous vehicles, industrial robots.
Yeah.
Exactly. If you're coding for speed right at the hardware level, C++ is still your language, and it probably will be until something fundamentally faster comes along.
Okay, this is where the analysis gets really strategic. Let's talk megatrends. Beyond mastering just one language, the industry is moving toward what our sources call polyglot programming.
Mixing languages.
Using the right tool for the right job.
That's right. And Gartner is heavily emphasizing the rise of AI-native platforms and, this is a key part, multi-agent systems. This means AI tools won't just be auto-completing your code, they'll be collaborating. acting as coding teams writing in Python, Go, and TypeScript all at the same time.
The implication there is huge. The human programmer's job is shifting fast.
It's a massive shift. Your role is moving from being the primary code writer to becoming the system architect, the supervisor, the orchestrator of these AI teams.
So if the AI is writing the code, the critical skill becomes less about, where the semicolon goes and more about strategic governance. And we have to address the roadblocks here. It's not just the learning curve of a language like Rust. The sheer pace of change is a huge obstacle. The field changes weekly.
Absolutely. Just keeping up with new models and frameworks requires dedicated effort. You have to be active in communities, on GitHub, on X, just to keep pace.
And that leads to this other challenge, right? The ethical one.
The ethical challenge is critical. Academic journals are warning about biases in AI. And the question for you becomes, how do you program ethically, especially when you're supervising an AI agent?
For example.
For example, how do you program a bot that you don't want to lie, or ensure it doesn't perpetuate biases from its training data? The human role is increasingly about strategy and ethical direction in a world where the bots can do the typing.
So let's bring this all back home. What does this all mean?
Yeah, let's recap.
We've covered a lot, but the strategic focus is pretty clear. Invest in Python for AI, master JavaScript and TypeScript for the web, adopt Rust, and Go for system speed and security. And make sure SQL is the absolute backbone of your data knowledge. These choices are backed by evidence in efficiency and security, not just market buzz.
And the final synthesis is that the future is absolutely hybrid. AI will be an incredibly powerful assistant doing a lot of the heavy lifting. But human innovators, that's you, are still essential for the direction, the strategy, the big ideas. The goal is to start small, pick one of those fun projects we mentioned, and just apply this knowledge. Get ahead of the curve.
And now, here's a final provocative thought for you to carry forward as the tech world accelerates. If AI agents will soon be able to code in teams, coordinating across multiple languages, what new human skill, beyond just technical coding, becomes the single most valuable asset for leading and governing these AI teams in 2026? Think about that and keep innovating.